Hey guys, today we're going to be starting a new unit all about polar and parametric equations. So to start out with, we're going to be looking at what a parametric equation is. So if f of t and g of t are continuous functions of t on the interval L, then the corresponding parametric equations are defined as x equals f of t and y equals g of t, where t is called the parameter and L is the parameter interval. So I realize it's a lot of words, kind of complicated, but all this is doing is if we have two separate equations, is there a way to graph them both on the same graph without having two different functions? Like, can I combine them into one function? So as long as they use the same variable, so in this case we're using the letter t, that variable, we call it the parameter. And also, it's not an indefinite interval. They will usually tell you between a certain number. Okay, so that's what a parametric equation is, just a combination of two functions. The parametric curve is the set of all ordered pairs within the parameter interval. So if x is f of t and y is g of t, instead of having x comma y, we're going to have f of t comma g of t. And all the points between the interval is going to make up our curve. The cool thing about these curves is that they're going to have an orientation, which means that your curve is going to go in a certain direction. So normally when we draw functions, there's arrows on both sides of the function. In this case, the arrows are only going to be pointing in one direction. Okay, so the definition's complicated, but the application is not, I promise. So let's look at this first one. It says, sketch the curve given by each set of parametric equations over the given interval and clearly indicate the orientation of each curve. So here are my parametric equations. X is going to be equal to t squared, and y is equal to 3t minus 2. And then this right here is our interval. Negative 2 is less than or equal to t is less than or equal to 4. There are a bunch of different ways to graph this, but the easiest way is to make yourself a table of values. So here's what I'm going to do. We have basically three letters to look at, t, x, and y. So our table is going to have three columns. T, let's make this x, and y. Okay, next thing is they specifically tell us, here's our interval, that t is between negative 2 and positive 4, including those numbers. So I'm just going to use the whole numbers between that interval. So negative 2, negative 1, 0, 1, 2, 3, 4. Let me space those out better so we can actually have room to write. Okay, negative 2, negative 1, 0, 1, 2, 3, 4. Okay, there we go. So I just got that from the interval here. It told me t is between those numbers. For x and y, we're going to use the equations that they gave us. So like starting with x, I'm doing t squared. So if I were to get negative 2 and square that, that would become positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. So that one was kind of easy, just t squared. For y, we want to do this formula, 3t minus 2. So we're going to plug in this number. So 3 times negative 2 is negative 6. Minus 2 is negative 8. Then what about if I plug in the negative 1? So that would give me negative 5. What if I plugged in 0? That would be negative 2. And then so on and so on. Keep plugging in the numbers. So if I plugged in 1, that would be 1. If I plugged in 2, that would be 4. Plugged in 3, that would be 7. And then plugged in 4, that would be 10. Okay, so there's my 3-column table. The problem is if we're graphing on a Cartesian plane, so like what we see right here, we only have an x-axis and a y-axis. There is no t-axis. So you're not going to plot these numbers here. We're only going to plot these numbers here, but we have to go in this order. So that's what orientation is, by the way. So let me put that definition right here. The specific direction of the curve when graphed in increasing values of t. So always go smallest to biggest. So let's graph this point first. 4, -8. So 4, -8, right here looks like. Okay, then let's keep going. The next point is 1, -5. Then 0, -2. 1, 1. 4, 4. 9, 7. And then 16, 10 is not going to fit on our graph, so can't really draw that. So there's our curve. So let me just connect the points. And it would keep going because it has to hit the 16. So remember, I'm going to label these just so we can see. This is when t was -2. This is when t was -1. This is when t was 0. T was 1. T is 2. T is 3. And then we didn't get to do t is 4 because that didn't fit. But it's important that you keep track of where your t's are at because this has a specific orientation. You have to indicate which way this curve is going. So the way we do that is by arrows. So on the very end, that's kind of an obvious arrow. We know it's pointing that direction. But on this other side, that does not mean that we're going to put our arrow going that way because that would be a totally different direction. All the arrows have to be pointing the same. So what you do is you go along your curve and you just make arrows. So this lets us know that when you're graphing, you have to start here and go that direction. Like it's super important. That is the orientation of the curve. Normally you won't see this pink part. I just wrote that in so you can see what I was doing. But you have to keep track of which number came first. Cool? All right, so these honestly, they're pretty simple. It's just regular graphing. So I have 2 more to show you. Let's look at our next one. X is equal to t squared minus 7. Y is equal to 1/2 t plus 5. And our interval is -4 to +4. So just like before, we're going to make a table with 3 columns, t, x, and y. From our interval, this is how much we have to have for t. So -4 all the way up to +4. So we have more points this time. Alrighty, so let's look at x. It's t squared minus 7. So if I were to plug in -4, so -4 squared is +16, but then minus 7 gives me 9. And then just keep going down the list. -3 squared is 9, minus 7 is 2. -2 squared is 4, minus 7 is -3. That would be 1 minus 7, -6. 0 minus 7 is -7. And then I think it's just going to reflect, so I can just... Oh, I'm skipping a number. -6, -3, 2, 9. All right, and now let's do our y values. So just be careful because of that 1/2. We are going to have some decimal values here. So let's start by plugging in our -4. Half of -4 is -2, but +5 is +3. The next one, half of -3 is -1.5. +5 is going to give us positive 3.5. So instead of writing it as a fraction, I'm going to do decimals just because I know we're going to have to graph these. So 3.5. Okay, if I plug in the next one, half of negative 2 is negative 1, plus 5 is positive 4. And then if I keep going down the list, it's basically going up by half every single time. Okay, so now we have some points to graph. You have to go in order, so you have to start right here. 9, 3 would be here. 2, 3.5. So I'm just going to go a little bit past the 3. Negative 3, 4. Negative 6, 4.5. Negative 7 is 5. Then it kind of goes back. So negative 6, 5.5. Negative 3, 6. 2, 6.5. And 9, 7. Okay, so there's my curve. This time both ends clearly have an endpoint. But I have to say, or I have to indicate the orientation of this curve. Which direction was it going? Did it start at the top and then curve down, or did it start at the bottom and curve up? So you have to keep track of your points, like I said. The first point was at 9, 3. So this was my first point. So starting from here, it went this direction, then back around. So let's put in our arrows so that we know which direction this curve was going. All right, and one last example. X is equal to 2t minus 9, and y is equal to the square root of t plus 4. Now our interval is going to be from 0 to 8. So again, with our 3 columns, we want t, x, y. Okay, our interval tells us that they want us to go from 0 to 8. So for our t's, starting at 0, 1, 2, 3, 4, 5, 6, 7, 8. These are the numbers that we're going to plug into each of the functions. So x is a linear function, 2t minus 9. If I were to plug in 0, that would just be negative 9. If I plugged in 1, that would be negative 7. If I plugged in 2, that would be 4 minus 9 is negative 5. Plugging in 3, so then negative 3, negative 1, then positive 1, 3, 5, 7. Okay, y is a little more complicated because of this square root of t. We're going to get a lot of decimals. Like normally radicals are better, but because we're graphing, decimals are going to help us more. So the square root of 0, if I were to plug in the 0 here, is still 0. Plus 4 is 4. So it starts off easy. Then if I were to put in the 1, square root of 1 is 1, plus 4 is 5. Plug in 2, square root of 2 plus 4. This is where it gets complicated. The square root of 2, I just put it in my calculator right now, and it's 1.41, keeps going forever. But we're going to add 4 to that. So this is going to be 5.41. Square root of 3 That's 1.73, so plus 4 is going to be 5.73. Square root of 4 is 2, that's an easy one. 2 plus 4 is 6. Square root of 5 is 1.24, so this will be 6.24. Tell you what, let me just give you all the values for the rest of them. Okay. So realize that these are not exact. I was rounding. I was doing 2 decimal places here. But we're going to graph these to the best of our ability. So let's see what we can do here. So starting with that first point, negative 9, 4. So that's right here. Then I have negative 7, 5. Negative 5, 5.1. So I'm going to go to about 5.5, or like, a little past the 5. Negative 3, 5.73. So that's a little bit closer to the 6. Negative 1, negative 1, positive 6. 1, 6.24. So that's like 6.25. 3, 6.45. That's almost 6.5. 5, 6.65. And 7, 6.83. So I was able to get my entire interval there. So let's connect all these points. So it kind of looks like a straight line. I promise it's a curve because of this square root. If you know what the square root function looks like, it does kind of make like a curve going that way. Now we need to draw in our orientation. Which direction were we going when we were drawing these points? We started here on the left and we ended on the right. So we need to put our arrows pointing in the right direction. All right, and that's it for graphing parametric curves. Tomorrow we will go over how to convert a parametric equation. So instead of having 2 separate equations to graph, how do we combine them and make it just one? All right, bye guys.